Okay, recap. This is what we covered before the year. Okay, so power given by differential equation, which is a change of work. So for this module, we use capital U to represent work, and if you work, you differentiate over time, it become power. Means it's a rate of change of your work, then it become power. Or in the another mathematic form, when you rearrange these two, um, your work actually is a change of your force and the position. Force and displacement. Force and displacement. So if these two go in the same direction, you get a positive work, right? So if your force go opposite direction with your displacement, you get a negative work. And your force go perpendicular to your displacement, your force go perpendicular to your displacement, there is no work done. Okay, so these are all the fundamental concepts that you need to be aware. um, and I already prepared your final exam question, so there will be one question for this chapter. Okay, so if you substitute the work equation into the power equation, all right, you will get the rate of change of your position or displacement, dr over dt, you get velocity. Okay, so force, scalar vector, right? Force multiplied by velocity, we get power. So mean the force and the velocity must be in the same direction also. Yeah, force and velocity must be in the same direction. Then only you get positive force. And the unit for power is watt, right? W-A-T-T, watt, or capital W, joule per second, or Newton meter over second. This is Newton. Velocity is meter per second, right? So Newton meter is joule. So meaning your work is one. Your work is joule. All right. So this is what we cover before the break. Then efficiency is you take output divided by input. Efficiency most of the time is tied to power, right? Output divided by output. Output divided by input. All right. So this is basic energy. So later um, we will talk about energy. Yeah. So energy, we still studying the typical energy, kinetic, potential, mechanical energy. Yeah. So far, these are the a few popular energy that we use to calculate. Yeah. So previously we looked at example number 4. So we will look at one more example. So I will skip this example. Okay, so we go to example number 7. Okay, so if you open up your tutorial handouts, you will have this question. So basically what you have here is a pulley system tied to the rope here with the parcel at the pulley pulley this one, and you have a motor that is pulling the rope here. Okay, it's the power of this machine. So this in chapter 2, when we talk about pulley, in chapter 2 when we talk about pulley, is without motor. Is without this one. But when you come to chapter 3, when we talk about power, right? When we talk about power, then power is work rate of change of your work. So when talk about power, usually power linked with efficiency. So it talk about your motor power in watt, or sometimes with efficiency. Okay. So you have all the parameter like you're familiar with in the previous chapter. For example, the datum. All right. So every time you see datum, and be careful on the direction of the datum. So for this datum here, positive P is to the right. However, for parcel C here, your datum is from here to here positive, means going down is positive. For C, going down positive. However, for P, going to the right is positive. Okay, and there's some information given over here. So motor M hoists a leaf certain mass there, so that the acceleration point P is, sorry, I think the unit here is missing, 1.2 meter over second square, because it's an acceleration, right? So there's a typo error in my slides here, meter over second square. Determine the power that must be supplied to the motor at the instant P has a velocity of 0.6 meter over second. Ignore the mass of the pulley and cable. He asks you to ignore the mass of pulley and cable and take the efficiency, right, equal to 0.85. You're given the efficiency of the motor is 85%. Okay, so before you start, at least you should know what is the definition of efficiency. Efficiency is your output divided by input, meaning you put in 100% of energy or 100% of your power, you will get 85% of your results, right? Okay, so this is the definition for efficiency. In test or in your exam, you won't see this symbol. I will just mention efficiency, how many percent. So in your calculation, you have to change the efficiency word, or if you forget about this symbol, it's fine. You just write efficiency equal to what, then write your calculation. Okay, so we have the situation here. We are given the mass, we are given the acceleration. Again, typo error in my slides here. Also, I think in same with your tutorial handouts, I think there's a typo error inside, because this one is acceleration. So acceleration unit is second over square. All right, so second square here. Determine the power that must be supplied to motor. So you need to calculate something happen to this motor M here. Velocity, so and so on. Okay. So how do we solve this kind of question? What is confirmed? You know that your efficiency is 85%, and you're seeing a pulley here. Okay, so when you have pulley, you know that you can link 2 point or 2 medium together by the length of the rope here. Okay, by the length of the rope here. Okay. So let's draw a free body diagram. Maybe I'll move over here. All right. So free body diagram, this is for parcel C. So parcel C, I use a square. And automatically, the first force you put inside the free body diagram will be your weight, your gravitational acceleration, W equal to mg, point down. Okay. So in your answer, in test or final exam, if you are mentioning about gravity, you can either write capital W, or you can straight away write mg around your arrow that is represent gravitational acceleration, right? W or mg, huh? So both same. Then you have 2 cable above the C here. Okay, so of course you can further break into pulley, and then there's 2 cable and then 1 cable down, like what we covered in chapter 2 when we talk about pulley system. So this one I straight away jump the steps to look at what happened to C. So there will be 2 tension cable pulling the top of the parcel here. So you have 2T, means 2 tension cable pulling this pulley here. Okay, so then I mark my reference datum Going down is positive from my datum. Going down is positive. And I combine my free body diagram with kinematics diagram with acceleration going down positive. Okay. Yeah, because in exam or in final exam, you don't have much time for answering. The time given is just enough for you to solve. So if you spend more than half an hour one question, you might not able to finish on time. So one question about 30 to 45 minutes. One question. So if you need to spend more than half an hour, means you need to answer the next question already, right? So if you take more time, then you might not have enough time to answer another question. All right, so this combine free body diagram with your kinematic diagram. So with acceleration going down. And I label as acceleration A sub C to represent pulsar number C. Okay. Any question on free body diagram? Everyone good? Prem, you okay?
Yes, sir.
All right. So I'll give you another maybe 10 seconds for those who are copying the slides. Okay, so for this module, you cannot run away from free body diagrams. Just for your give you some hints for your coming exam and test. You will always see the first section in the question. It will guide you to ask you to construct a free body diagram. Okay, so make sure I can say 4 questions. All questions have free body diagram. So make sure you are good in free body diagram, and yeah, make sure you're able to draw the correct one now. Okay, and it will be a scenario-based kind of question. Yeah. Okay, so we start with the Newton equation, F equal to ma. So in this case, if you view this diagram, there's no horizontal force. They only have vertical force. So we only focus on the y direction in the F equal to my equation. So all the force in y direction equal to mass multiplied by acceleration in y direction. So you put all the force in the free body diagram into the left hand side, all right, according to the reference or datum direction. So going down is positive, all right, so you should be able to write the next steps of the equation. So you have W minus 2T going down positive, W positive, going up negative. So W minus 2T equal to mass multiplied by acceleration of the parcel C here. So if you look at the equation, W you can find. W equal to mg. Mass C is given. Gravity, you know. Okay, for this module, gravity is 9.81, not 10. Unless the question state use 10. But throughout this module, gravity is 9.81. Yeah? Tension, we don't know yet. So far, we don't know. All right. Yeah, tension actually you can find. Tension actually is free, is related to your C weight here. It's pulling the same weight that is going down. Yeah. A you need to find. Okay. So you get the first equation. W equal to mg minus 2t equal to 2ma. So equal to may. So we will link. There are two unknown here, T and AY. So again, every time you see there's a pulley involved in the question, you need to think back how you solve pulley question. Pulley question, there's a set of standard procedure when you solve pulley question. Fixed already. If you go and study the trend of solution, actually the same, right? You find the length of the cable, then you differentiate the length of the cable, become velocity and acceleration. It depends on the question, all right? Then you solve for the unknown. So I give a hint in my slides here. You use the line to find the missing parameter here. So your L equal to 2SC plus SP. How you write the equation? How you write this equation here? L equal to 2S plus SP. So the total length of the cable is from datum here, go down, then here, go up, and then the distance from here to here. Okay, so SC, you have 2 SC plus SC here, plus here you have 2 SC plus SP here. So that's why you arrive at this equation, L equal to 2SC plus SP. All right. So in this case, when you differentiate over time, you can, from this equation, you can find the velocity and also acceleration, yeah, as what we practice in the pulley chapter. Okay, so in this case, because we want to find the acceleration, so we differentiate 2 times of this equation over time. So when you differentiate, the length become speed or velocity, and you know that the length doesn't change over time. So if it becomes 0, so the displacement, if you differentiate over time, you get velocity. You differentiate one more time, you will get acceleration. Same with this one also. So here link with your C object, AC, and your P object, acceleration. So here actually you have link with 2 objects here. So from this equation, you know that you need to solve for this object here. Right? So from here, you know that your C and P actually link with half. Or you can say that 2 AC equal to 1 AP, meaning 2 to 1 ratio. Right, 2 to 1 ratio, but you rearrange your AC equal to minus half AP here. All right. So you have 2 equations here. You read the question. Okay. You read the question. Are you able to find AC? The question gives you something about this one. And there's a negative sign there. There's a negative sign there. In this case, if you see negative sign, it means C and P actually they are opposite direction. Okay, they are opposite direction or with each other. Okay. Do I need to point to you where is this value? Any one of you don't know what is AP? What is the acceleration of P? Again, the typo error. Typo error in my slides here. Meter over second square. So once you have you substitute the value from the question itself, you have your AP. Once you find your AC, substitute inside. Okay, here your AC is Y, yeah, correct. So this is AY. Then you just substitute lah. Okay, so you substitute the value. Okay, you get what is your T. So your AY here, this AY actually is AC, because this equation referring to the object C here. Okay, so from here we solve what is our tension. But the question asks us to solve for power. All right. So before we move to power, any question on the tension value? Anything on the slides here you don't understand? Stop me and ask me question.
So far, okay, sir.
Good, yeah? All right. Now, once you find all the forces, the question asks you about power. So you need to be firm about what is the definition of that particular word. For example, power. Power is force and velocity, right? Force and velocity. Work is force and displacement. So you have to understand. All right, so next move to finding the power. Okay, so you have acceleration of yeah, okay. Yeah, so you have the velocity given in the question, 0.6. So you know that the power is force and velocity. So force you define because you already find the tension cable 2T here. You define the tension of the cable, each cable, how many tension already. So basically this tension cable link with the tension of your P here. All right, so this is the tension cable. Don't use the 2T. Don't, after you find the 2T already, you use 2T. You need to look at the diagram. So you have a two cable. So the only things that link to the P is cable. What this cable need? Single cable. So that's why you use the T value 182.2 for this case. Because this cable here, same value as this cable. So that's why when we go back to the power equation here, so power equal to tension times the velocity of the cable of P, which is here, this velocity, the speed of this velocity here, and it's given in the question 0.6, right? So you put in the tension, put in the velocity from the question, you get power. Power is in watt, right? So you can put your answer in Newton meter over second, or you can write as power equal to watt, okay? Power equal to watt. Okay, so this value is the power need to pull, is the power need to pull this puzzle. Okay, the answer that you find in red color here, yellow color here, is the power that you need to pull this object with acceleration so and so, velocity and so and so. And you're given the efficiency of the motor. Question asks you the power that must be supplied to the motor. It do not ask you the it do not ask you the, it do not look for the power that need to pull the object C, but it asks you what is the power, the total power, the 100% power need to supply, because the power of this one is actually is 85% that's supplied by the motor. You need to find out the original power. So definition for efficiency is output divided by input. All right, output divided by input. So you just put in the equation, rearrange the equation. You have the number on the left hand side. You have the number on your calculation output. You need to find what is your input here. So you rearrange the mathematics model. substitute the value. This one for output, efficiency 85% or 0.85. Okay. So the energy you need to supply to this motor is 129 watt. Okay, and not 109.3 watt. Yeah. So this is a very lengthy question that can take it as 25% question, 25 marks question, right? And for your info in your coming test or exam, I'll be very generous in free body diagrams. Huh? So they will be a very high point for your free body diagram. So because why? Because once your free body diagram is correct, the rest also just follow the standard procedure, right, or standard strategy to solve, right? So what my concern is that if you're not good in free body diagram, then something will be missing in your equation, and the rest will be you have a lot of error in your calculation. So when you solve your question in test, always have a habit of writing the general equation. Yeah, have the habit of writing the definition of that particular term. For example, efficiency. What is the, for example, if you go back to chapter 2, ask you about acceleration. Given the velocity, then you need to convert from acceleration to velocity. Then you need to write the definition of acceleration, a equal to dv over dt, something like that, right? So you need to write out the general formula. For example, the radius of the curvilinear curve and so on. So all these general equations will help you to secure some marks. And there is a marks allocated for general equation, 1 to 2 points for each of the general equation that you need to use for each question. So basically, if you write the correct equation, you will score points already. Okay, so basically can say that it's very hard to fail in our module or in module that I teach, right? As long as you know what is the correct equation to use and also how to draw the relevant diagram. Okay, so I believe there's no any question you want to ask me before we move on. Any question?
Yes.
No, okay. If no question, let me check. If no question, we go for a short break. Go for a short break, and then we come back. Let me end the recording.